So what we want to do here is to build a new engine, to build a new prediction engine around time series. So why time series? Or what is time series to start with? So time series is essentially a sequence of data points that every data point is annotated by a time. So let's say what you see on the screen is we have Google and Apple's price. This is the closing price of the past week. So that from the data point, we can tell that this is the closing price of Google, this is the closing price of Apple. And why time series is so important and interesting is that we know that there is a time annotated with each data point. So that we know that at a certain point that when Google is of price $1,219, the same day Apple has a price of $530. So using this kind of data allow us to extract a lot of useful information from the underlying objects, which makes prediction extremely interesting. So in the following of the talk, I'm going to use a lot of cases from the stock market, just because like all the information is public, so that I can easily use the data. But it doesn't confine our scope in like financial market. The scope of this talk is just to illustrate how important and how fun it is to work with time series in a prediction engine. So for time series, there's a lot of application for forecasting. So the first is financial, obviously. All the like hedge funds are trying to predict the price of stock market, the foreign exchange, the interest rate of different things. If you're successfully predict the stock market, you will make a lot of money, and I may not be here if I'm successfully doing that. So second, that would be the marketing or sales to prediction. So one of the very interesting problems that we have is to predict the lifetime value of a customer. So say, we want to tell if a customer is high value bringing from the first purchase in the store. Because like a lot of companies, especially if they're in retail, if they are able to tell if a customer is going to bring a lot of future value just from the first few time series data point, they want to spend a lot of effort and salespeople and money just to extract a lot of money or value from that customer. So this is what we can earn or gain from doing a time series analysis on the customer, on the customer. Third, that will be operation research. Say if you're a Safeway, you may want to build a prediction model about like how fast your bread or like your meat or ham things go. Because like you would like to refill your inventory before they are all gone. So this is another different type of inventory, different type of time series, which is based on number of inventory in your warehouse or in your store. So that you want to predict ahead of it, so that you can like plan ahead, so that you will not open an empty store. The fourth one is called web traffic. It is very important for a web company to predict the future traffic. The reason is you may want to set aside more servers to serve traffic on weekend because like a lot of people will be watching YouTube and Netflix. And at the same time, from a search engine or from a ad server point of view, being able to predict how much money we make the other day is extremely important. Say for example, if you have a company which makes $100 million from ads every day, you want to have a really good forecast, because whenever there's a day that your company report that you're only making $50 million for a day, you will be really terrible, because like if what is actually coming back from the system is so much different from your forecast, it means that either it is like your forecast is wrong, or your system is doing something really terrible, or you're forgetting charging your customer or something like that. So this is extremely important from an implementation point of view or from a system point of view to have some kind of forecast so that you can always try to cross-track with the system that you have. So the last one, we all know weather forecast. This is extremely important. We want to know whether or not to go to work or to go to run tomorrow, because like, and this all kind of forecasts are all based on time series of some form. So why do we always want to emphasize time? time is so important in the sense that it's just a sequence. We can extract a lot of information from time, from the trend, from the sequence of data itself. So these are three important aspects in time series. The first one is about event co-occurrence. It is extremely important for when we do analysis that when things happen at the same time, we can always tell that something is happening or there is some relationship between the two objects if they always happen or if they always behave at the same time at the same way. The second part of time we can also always consider is the granularity. So when we always talk about something in monthly or weekly or secondly, using a different granularity, we will be able to expect or exploit different property or the structure from the object using a different time granularity. So whenever we do an analysis of a forecast using time series, it is always so important to also think about like what kind of granularity we are talking about. And the third one is about duration between events. So because we are talking about time, so for every 2 points in time, there's always some distance. That kind of distance also always provides us some kind of information about the object. So that this is another important aspect of time, which is the duration between consecutive events. All right, so time is very interesting. On one hand, time can be an absolute object or absolute measure, so that when we treat time as an absolute measure, we can cluster things together because they always appear or occur at the same time, just like stock market. This is a screen cap of 4 stocks in the stock market recently, since like October in 2013. So the question is, what can we tell? There are 4 time series here, and obviously there are 2 clusters. The question is what we can tell from these 4 lines. And using a very simple analogy, we can see that actually the top 2 lines somehow behave similarly, and the bottom 2 lines somehow behave similarly in a different granularity. What it actually means is like, for the red line and the yellow line, when they both go up, they always go up and go down in almost the same way, in almost the same magnitude. The same thing applies for the blue line and the green line, which is like, they always go to the same direction, but maybe of different granularity. If we are taking a weekly or monthly view of the green line and blue line, we can tell that they are pretty much the same thing, or they are very closely related to other. And exactly because from the graph, from time series, we can tell that because they always move together, they are probably from the same industry. And in fact, you may want to guess what they are, and here's the answer. The red line is PG&E, we all know that. We all know what company it is. The orange line is called Excel Energy, which is also a utility company in Minnesota. And for the bottom 2 lines, they are not so similar, but they are dramatically different from the top 2 lines, which is they are Toyota Motor and Ford. So this example is to illustrate that actually just from the time series, we are able to extract a lot of very interesting information just from the time series. And actually in academia, people can classify stocks just by looking at the daily return. There's a paper by Doe and Eklund. They are from UCSD. What they published a paper is like based on previous daily return, based on the it's running out of battery. Based on the daily return of some SP 500 stocks, you are actually able to classify all different company by the daily return. For example, whenever, in this case, for cluster 1, it is all like resource or utility company. This cluster 2 are retails. Cluster 3 is financial company. Cluster 4 is about some real estate company. And they do this classification only based on the daily return of the stock price. So this shows how important and interesting that just look at time series, we can extract a lot or exploit a lot of information from the object. So I talk about that time can be an absolute value. And at the same time, time can be also a relative value. In some applications, we don't actually care about when the user starts doing something, but we care about their user pattern or the duration that happens between two events. Say, I go to Safeway every week to refill my grocery. It doesn't really matter if I go there on Sunday, or on Monday, or on Tuesday, but what really matters is that I go there every week. So here's an example. The question is, which of the two, so you can see that this is a table.